Okay, here we are. I have taken the Docker Compose overkilled to do app and I have deployed it onto Minikube in here, which from those manifests you can deploy it onto a full-blown cluster if you want, into Azure or Amazon EKS and stuff. So anyway, I just wanted to kind of run over how that's done, how the translation is done, maybe run through some of the manifest that we've built out. I did use Compose initially. I was trying it to the tool Compose to convert the Docker Compose file over, but the got a little unwieldy. I was at first I was like trying to create a script to apply them and stuff, and I was like, man, I didn't like the way they were turning out. So what I ended up doing is kind of picking them apart, and I created more or less manifest. That kind of consolidated each service type or whatever you want to call it. So we have like the API gateway, contains its config map, its and the deployment in the service as well. So each one of those we can run will end up deploying, and once you walk through it, it will hopefully make more sense to you, not me, because it ain't gonna make sense to me ever. Anyway, we're gonna start up Minikube. This won't take long. If you have Minikube, or if you have Docker installed, and you use Docker as the runtime for Minikube, it's actually really easy. You just install, you just get the Minikube binary, add it to your path, and away you go. So this is starting up, as you can see here in right here. So Minikube, that's the only thing it'll start, the only container here that you'll see. But as you'll see, we'll have plenty of containers running inside that Minikube. All right, so I do have, this is all on GitHub right now. It's on a different branch. But I'll create a pull request and review it. And if it looks good to me, as the person who wrote it, I'll pull it into master, and we'll see how we'll get rid of that branch. Anyway, enough of jokes. Let's see here. So we got Minikube started. We're going to enable the Ingress add-on right away because why not? We're going to need it. I'm going to double click on that just so I can copy and paste this. It's going to open up there. Getting to the containers. So the containers before, when I was building them, I didn't use like multi-stage or anything like that. I just kind of built them. I was just trying to get that project done. But since then, I went back and I've redone, I think, all of them except for maybe the front end, because the front end was already using like a really, small image. And you can actually really see a big difference with some of these images. So we went from, 6 gigs on the Haskell to 2 gigs and 2.3 on the Erlang, 2 gigs on the Go and Rust ones, as you can see here in a second. So let's do so Docker image ls. You're going to see, like, really quick, we've got some fairly small images for what they were. The delete service, and I think the updates are like one of those, the Haskell service, which was the create. It's right here, create. Is 171, was 6 gigs. So using multi-stage building for containers and create or your images makes a lot of sense. Build everything, then copy over just what you need, and to like a skinny image, like a slim alpine or something like that. Whatever will run. All right, so we need to copy the images into Minikube in this case because we haven't, there's no way for Minikube to pull those images. So what we'll do, we have to do each one, but this will be kind of quick because they're kind of small. They're small. We'll get these in here and then we'll start running the manifest. for each one. And so let's look at it this way. So we'll start deploying the manifest. We'll start with the database, then we'll go through the CRUD services, and then we'll do the front end, the API gateway, and then the Ingress, and then we should be able to see it. I won't go into detail in this video of the metrics, but you can install like Loki and Prometheus and have them basically like Grafana look at it and display stuff on the front end. This here is basically a direct pull from this blog post from Grafana. The only real difference is I pulled down the manifest that you're going to need. Yeah, I think that's about it. But if you want to see Grafana, it works. You can continue on through this README and actually deploy that. Go to this link here. The blog post will tell you how to go into Grafana and link up the data source, and you can start building dashboards based on that. All right, so let's do a Minikube image ls, and we're going to see all of our images here. If you don't put those there, it's going to fail. Another thing to do if you're doing this with your own images or something in the future, let's take a quick look at like create service. As long as you have the image there, you might copy it over, but if you don't put image pull policies, it'll still fail because it's going to try to reach out and pull from like Docker Hub, even if the image is there. If you don't put this here, it'll fail. So learn from experience there. All right. For this next little bit, which we're going to close this, we'll go here. Let's double click here. So, because I'm going to be double clicking and it always goes here. So what we'll do, there are tools like, in my case, I'm going to use the tool called K9, K9s. So we can kind of watch them, the pods come up and down. This tool is really nice. It's like a CLI version of like K-Lens or whatever. I think it's KubeLens. Very good tools for working with a cluster or Kubernetes in general. But as we deploy these, we'll see our pods start spinning up in here. It's a really basic system. I don't have like replicas and all that for each one of these because my to-do service isn't as popular as I thought it would be. Anyway, not a lot of money made there. As a matter of fact, we can host the whole thing locally with no port forwarding on an internal network, and it works the same for everybody else that's trying to hit it. Okay, so our database is coming up. The database is the one fairly interesting manifest, which I don't want to go into detail. I kind of want to keep the video short. We're already 8 minutes. Might as well jump over and look at it real quick. So you can do init containers. So init containers will run to completion before anything else starts. So what this one's going to do is this container will start up. It's going to copy the init SQL from this config map, basically. Here's your init SQL config map. It copies that into another volume that the normal container is going to use. And anything in this folder, or I don't know if it's anything, but I know for sure the init SQL one runs. I think anything in any SQL file in there will get run, but I actually don't know that for sure. All I know for sure is that one does, right? On the first time it boots up this container. So once that one happens, we get all that to-do stuff, from the original, SQL file that we wanted to do. Anyway, let's move on from that. And so we're going to have our database is up. Let's get our create service going. Oops. When you highlight in the console, so there's our read, there's our update, there's our delete. They're all going to spin up pretty fast. The containers are there, and they're small, so the images. So here's our gateway. The gateway one was a little bit more interesting, and we'll look at both the gateway and the Ingress. Everything else pretty much acts like Kubernetes networking, cluster-wide, as long as the pod names are the same. They can pretty much hit. Even if the cluster name changes, you can just if you're using the FQDN, so you would put like cluster or service dot cluster or something like that. But you'll see like one easy way to see this is look on the API gateway, and I didn't have to change this the way it works. The only thing different really is that when we use our Ingress controller, where'd you go? Where'd you go? Here. The only real difference is we're saying, hey, anything that hits me on slash just goes here, or basically anything that doesn't match slash to do. So anything that matches slash to do goes to the API gateway, which is something that I built, versus the Ingress controller itself. And then anything else basically gets hit goes to the front end. So I think the only thing with all these up and running, and you can use like the K9s tool you can use to like let's look at the DB, MariaDB, hit enter, and you can see the two containers there. If you get out, it'll say 1 of 1 running, because if the init container fails, the whole thing fails. It actually won't even start, which is the nice part about init containers. They're not like a sidecar container. Anyway, you can get logs off of these, so you can just hit L to get logs. Anything you can do with CTL, you can actually do with, well, I should say that. You can do a lot with K9s. That's all there is to it, I guess. You can even delete. So, like, say I want to delete that pod, and because we have the deployment in there, it'll actually redeploy. So it's good to delete, but then it's like, hey, I'm coming back. Okay, let's do a Minikube tunnel. And that should put us, basically we're having to use the tunnel because we don't have a load balancer. I think it's the best way to say that. And because we put the Ingress on localhost here, we should, let's go here, localhost. So there's our to-do app. It is up and running. The docker-compose stack is not here. We are we have deployed the Minikube, and that'll persist any reloads because it actually is hitting the database at this point. I think one easy way to see that, let's do, that's here. Maybe logs here. And then let's delete the profit one because that's not gonna work. We didn't get a log off of that. I don't know why. Let me delete one. I'm expecting a log. It may be my log level, so let's do a log on the API gateway instead. Yeah, so you'll definitely see them on here. So if we do have fun, yeah, see. So we did a post. The to-do got sent off to the, but I went in depth on this one, I think, with the Docker Compose, but that's, because of the post here, it gets sent off to the create service, which is right there. And then you can probably, I'm not doing any log on that, and I think that's the Haskell one. So yeah, that service, I didn't get in really depth with building that service out, but I might. It would be kind of fun to go ahead and extrapolate the the whole service onto the Haskell stuff, just so I can learn it right. Anyway, I think that's all I'm going to show for right now. I'll be more than happy to answer questions or whatever. So the next step of this, since we have all the manifest, I think the next step would be to start splitting apart the repo, and that way we can eventually move toward like Argo Flux type of situation where you're doing like the GitOps thing. So you got end-to-end automation. So it'll watch the repo for changes. When the changes happen, it can build, pull down, and start up a new pod or a new deployment. Well, once an image gets updated. Anyway, I think that's all I'm going to show for right now. I don't really, I can dig into each one of these, but the repo, the GitHub, my GitHub will have this on there. You're welcome to go look at it, and if you have questions about it, ping me with in the comments. Yeah, the only real I mentioned really quick before I go. I mentioned those multi-stage builds earlier, and most people know about that, but just in case, I'll drop over to like the Rust one. So you're using, you can look at the commit history or whatever, and you can see what I've done. Basically, we're using a much larger image that has everything it needs to build these, build the in this case binaries like Go as well. It's gonna be the same, sort of the same. It's a little bigger, so it'll build, and then from that build, which is just aliased here, you don't always have to alias it as long as you reference it. I think here you'll see I'm just going to from 0, which means where are you at? One of these I just name, maybe it's the update. I don't know. I've been dealing with this update. Read. Where's my Docker file? Okay, one of these I did that. There you go. So as you can see, I didn't alias it here, but I'm copying it there. So anyway, different ways to do that, but it definitely makes images much smaller and being able to run them a little bit more convenient. All right, that's all I'm gonna do. Thanks for watching. If you got feedback, let me know in the comments.